Hello, and welcome back to Science and Engineering, the guide. In this video, we'll be covering the initial steps in planning out the experiment for your research projects. At this part of your project, you should have your topic selected with a scientific question along with background research conducted on that topic. In the previous video, we mentioned that this video is going to be covering some essential aspects of the science and engineering process. This means you should know everything there is to know about your topic. This will help to effectively design your experiment. You'll notice that most of the steps we discuss in this video have been covered in the scientific method video within the context of the whole process. In this video, we'll apply those steps to your project. Before starting to plan out your experiments, there's two elements that you need to develop. One is your hypothesis. Make sure you understand how to make a hypothesis theoretically and how it fits into the process of the scientific method. For a refresher, the hypothesis of a project is an educated guess that the scientist forms to describe what they think will be the answer to their scientific question based on their prior knowledge and background research. It's essential to realize that it's acceptable for your hypothesis to not match the outcome of your experiment. Its purpose is not to be correct. It's an educated guess. It wouldn't be a guess if you were supposed to always correctly predict the outcome. However, if you do have an incorrect hypothesis, you want to make a new hypothesis and go through your procedure, something that we will talk about later in the video. Since you've already conducted the background research on your topic, it's time to form your hypothesis. The main thing you utilize when writing your hypothesis is the if, then, because format. This is what is generally used in scientific papers and is the best way to cover all the aspects that you need to cover efficiently and clearly. Here are some examples to help formulate your own hypotheses. We showcased some hypotheses in a previous video, but here's an example just for reference. If plants are exposed to sunlight, then plant height will increase because of the plants performing photosynthesis. After forming your hypothesis, the next step in the process is to describe the significance of your study, which Seashell will now explain.
The significance of study is the second crucial element that we need to talk about when starting to plan your experiment. As we talked about in the scientific method video, the significance of study is a representation of the purpose of your project. It states why your project is important and how it's beneficial to the world. You should have already had a purpose in mind when selecting your topic and your scientific question, because as we mentioned in the selection video, it's very, very important to create a project that has a profound benefit to a lot of people. This isn't necessarily part of creating an experiment, but it is a significant part of the pre-experimentation project that everyone should have before going through. So this is the significance of study document. You can see here that we're going to be writing down the scientific question, the why is your project important, and who your project is important to. For the last section, these are the people that you feel are going to be impacted the most by your project. This can be anything from companies to people groups to specific cultures or anything like that. You should expand here on why this would affect them and how you determine the scope of your project to be this much. I want to emphasize that the significance of study can be exaggerated as much as you feel reasonable for your project. You should make your project sound as important as possible and make sure that you don't limit your significance of study yourself. Jay is now going to talk about the variables of your experiment.
Now about variables. As we've mentioned in the past, your experiment will have three types of variables: an independent variable, a dependent variable, and multiple control variables. To recap, the independent variable is the aspect of your experiment which you will change. In other words, you'll be changing this variable and observe the effect of that change. The dependent variable is the part of your experiment that represents what changes as a result of changing your independent variable. You change the independent variable at your own will. In other words, it's not dependent on anything. However, the dependent variable is dependent on the independent variable. It changes based on the independent variable. This is exactly why it was given the name dependent variable. The third type of variable is the controlled variable. If your project follows the concept of scientific inquiry, your experiment will have two groups, an experimental group and a control group. The only difference between these two groups is the independent variable because it will be altered. Everything else must be kept the same between these groups. The aspects of your experiment that are kept the same are represented by your control variables. Each part of your experiment that is controlled in both groups is considered one control variable. It's important that your experiment has multiple control variables because it ensures that the only thing that's affecting your dependent variable is your independent variable. In other words, you don't want anything other than your independent variable affecting your dependent variable. This is because the purpose of your experiment is to understand the effect of your independent variable, which can only be done if the independent variable is the only thing that is affecting the dependent variable. Otherwise, your results would be inaccurate since you're not truly observing the effect of only the independent variable. Taking a look at the variables document, we can see the things we just talked about. So here is just another template for you guys to store more information about your project. And here you can list your scientific question, independent variable, dependent variables, and controlled variables. Just a side note, you guys should create a folder in your Google Docs account just for your science and engineering. This is just a tip for organization, and we recommend you take it into consideration. In the example, you can see the scientific question, does fertilizer make a plant grow? Next, you see the independent variable, the thing you change. In this case, it's the amount of fertilizer. After that, you can see the dependent variables or the things that you're measuring. In this example, you're measuring the growth of the plant with different units. Finally, we have the control variables, the things we keep the same. In this example, you have things like the same type of fertilizer, same pot size for each plant, etc. Next, we're going to talk about materials and procedure.
Afterwards, you guys will start on the materials and procedures for your experiment. This is going to be your first direct interaction with the physical happenings of your experiment. Materials should be a bulleted list of all the things that you utilize. This includes anything from building materials to tools that you'll use to test your model. Everything starting from even a pencil should be included. You'll have a chance later on to edit this list when you're writing your final report, but at the moment you should write everything down. Also, you need to write down specific measurements for specific materials and the quantities of each material. You should always include more information than what is required. With your procedure, you should write a numbered list of steps that you took to perform your experiment. This is not just how to make whatever you're testing, but also the steps you took to specifically test that model. Your goal should be to allow anyone else looking to reproduce your results without any external knowledge and by just looking at your procedure. To do this, like with your materials, you should always have some type of measurement of some dimension. This sounds complicated, but it basically means to add something like weight, length, etc.
This is the end of the video, guys. Next video, we will cover more about the experimentation process. We are going to link examples of all these docs we've done in past years in the description below. We have already covered a lot of information, but we believe that you guys can do it. Also, as always, feel free to reach us at our email, which is listed on the slide, or feel free to comment below. We will make sure that we're responding to these comments as soon as we can.
This is the science.
Somehow.